Hello everyone, welcome to my Maths channel. For today's additional Maths class, I would like to share with you one of the best teaching method on permutations with condition. Alright, so this video is from Maths Pop. So I really hope that my sharing do help you to have a good understanding of permutation with condition. So have fun.
Like that. 2, 3, 4, 5, 6, 7, 8. We have 8 letters, right? So guys, how many ways can you arrange 8 objects? How many ways can you arrange them? A factorial, right? For 8 objects, say 8 letters, there are 8 factorial ways of arranging them, right? Okay, that's easy. And but guys, watch out though. Do we have any repetitions? C-O-M-P-U-T-E-R. No repetitions, right? So that's good, that's it. Right? Because remember, anytime we have repetitions, we have to divide out those repetitions, right? But in this case, we don't have any repetitions. So that's it. Simple as that. A factorial. Next. Now, check this out, guys. For the second question. Now, if the vowels must be together. So because in English, out of 26 letters, how many vowels do we have? We have 5 vowels, right? What are they? A, E, I, O, U, right? Okay, so now, guys, here it is. For the second question here, we are starting to add what? Restrictions to this question, right? Yeah. And whenever we have a restriction, what do we have to do? Guys, no big deal. We must deal with restrictions first and then proceed with the rest of the questions. Okay, here it is. Now, if the vowels must be together, so now computer, C-O-M-P-U-T-E-R. So what are the vowels in the word here? Yeah. Do we have A? We don't have A. Do we have E? Yes, right here. We have E right here. So that's a vowel. Do we have I? No. Do we have O? Yes. Do we have U? Yes. Also, we have 3 vowels. And they must be what? They must be together. Right next to each other. Okay? So an example of a successful arrangement would be what? Say like this. Say O, U, E, and then and then C, M, P, T, R, right? Let's see, C-O-M-P-U-T-E-R. Yeah. So guys, an example of a successful arrangement would be this, where we have what? Where we have the vowels together, right? See, the O, U, E, right next to each other. They are together. Can you see that? They are together. Okay, so guys, here it is. So, in order for O, U, E to be right next to each other, together, now, how many arrangements are there? Should we expect to have more arrangements than A factorial or less than A factorial? Less, right? Yeah, but what's the actual number of arrangements? Let's go. Okay, let me teach you a trick to do this kind of question. Guys, here it is. So what's the restriction here? The vowels must be together. Hey guys, if they have to be together, you know what? Guys, take out a box Okay? Take out a box and actually put the 3 letters inside that box. Since they have to be together, you might as well just what? Put them in the box together. So however way you arrange them, they are always together in the box, right? Yeah. So guys, here it is. So guys, because O, U, E, they must be together, so I'm gonna put them inside a box. Okay? So guys, here. So once you put it inside the box, okay, don't even think about what's inside the box. Treat them as just, one object. Okay, one box. Okay, guys? And then, guys, this is what I want you to do. This is actually what I want you to do, guys. So now, here. Guys, I'm gonna put the rest of the letters in an individual box. Okay, so I'm gonna put P in a white box. I'm gonna put M in a red box. Okay, and I'm gonna put C in a blue. Oh, I already have blue. I'm gonna use in a green box, and I'm gonna put R in a yellow box. Okay, and at the end, I'm gonna put T in a pink box. Okay, you see that? So guys, each box contains one letter inside, okay? So white box has the letter P inside. The red box has the letter M inside. The green box has the letter C inside. The yellow box has the letter R inside. The pink box has the letter T inside. Except one box, except we have an extra large box where we have 3 letters inside. But guys, don't worry about the 3 letters. So guys, here it is now. Now rethink this question. Rethink this question. How many ways can you arrange 1, 2, 3, 4, 5, 6? How many ways can you arrange 6 distinct boxes? They are distinct means they are all different, right? They are all different colors. So how many ways can you arrange 6 different boxes? There we go. 1, 2, 3, 4, 5, 6. So 6 boxes, we should have 6 factorial arrangements, right? So we should have 6 factorial arrangements. That's it. Right? Like moving the box around, right? So we should have this many arrangements. Okay? So let me make a note. 6 factorial comes from what? Ways to arrange 6 distinct boxes. Okay, guys? Yeah. Now next. Guys, however, don't forget, there is one extra large box, right? And inside this extra large box, how many, focus on the extra large box right here. Inside this extra large box, how many letters do we have inside? We have 3 letters. And these 3 letters can what? Can arrange in many different ways among themselves, right? Yeah, so guys, for 3 letters, how many ways can you arrange 3 different letters? 3 letters, we have 3 factorial ways to arrange them, right? So we have to multiply by 3 factorial. Okay, and once again, let me make a note. Oops. So guys, This 3 factorial comes from what? Comes from the number of ways we can arrange what? 3 letters in the extra large box, right? So this comes from ways. We have 3 factorial ways to arrange these 3 letters, to arrange the 3 vowels, right? 3 vowels inside the extra large box, right? Inside this extra large box. Inside the extra large box. Okay? And that's it. That's it, guys. That's the total number of ways we can arrange these A letters with the restrictions such that the vowels O, U, E are always together. They're always together, right? Because you already put them inside a large box, right? So it doesn't matter how you move this extra large box. They are always together, right? Yeah, that's it. So the answer is the final answer is 6 factorial multiplied by 3 factorial. We have 4320. That's it. So there are 4,320 ways for us to arrange these A letters having all the vowels together. Okay? Good. So let's talk about the last question. Right here. Okay? How about vowels must not be together? So guys, oh, by the way, the answer for the second question is 4320, right? So I'm going to write it here, okay? 4320. Okay? Good. Okay, now let's look at the third question here. Okay, now the question gives you another restriction. Now, guess what? The vowels must not be together. So that means what? The vowels O, U, E, right? They cannot be together. So it's kind of, so question 3 is the opposite of question B, right? Of the second question here, right? Yeah. See, the second question here is vowels must be together. Now the third question, the complete opposite. Now the vowels cannot be together. How do we do this question then? Guys, let's think about this. Let's start from the first question again. Guys, how many ways can we arrange the A letters in the word computer with no restriction? With no restriction. So guys, think about this. With no restrictions, no restrictions means what? That's all the possible arrangements out there, right? So all the possible arrangements how many are there? We found the answer to be a factorial. So the answer is a factorial. A factorial, right? So the first arrangement is just the most ordinary arrangement. C-O-M-P-U-T-E-R, right? So guys, give me another possible arrangement. Easy. We can go C-O-M-P-U-T-E-R, right? That's another possible arrangement. And guys, we can keep going for a long time, right? Yeah, so let's keep going. Okay, and then another possible arrangement could be, like C O M P U T E R, right? That's another possible arrangement. Okay, good. Come up with one more. Give me one last one. Easy, right? We can just read this word backwards, right? Read the letters backwards. So we're gonna have C-O-M-P-U-T-E-R, right? Right? That's another possible arrangement. Okay? So guys, since this question is talking about having three vowels, because in this question we have three vowels, right? We have O, U, oops. We have O, U, and E, right? For example, second question, if the three vowels must all be together. The third question, if the three vowels must not be together. Okay, so since the question are talking about whether three vowels are together or not together, guys, let's actually look into the three vowels in each arrangement. Okay, check this out. For the first arrangement, so what are the placement for those three vowels? O here, U here, E here. So the three vowels are not together. Not together. Okay? So guys, you know what? So the first arrangement here actually satisfies question number 3, right? Vowels not together, right? Now, how about here? How about for this arrangement right here? So where are the vowels? We have U here, O here, E here. Are the three vowels together right next to each other? No. So three vowels not together. So guys, guess what? For this arrangement here, that's another successful example for the third question right here. Vowels not together. Three vowels not together. How about this one right here? Where are the vowels? Where are the three vowels? O, U, and E. Ooh, hey guys. In this arrangement right here, in this particular arrangement, guess what? The three vowels are actually together. Right? So this particular arrangement will be a successful example for what? For the second question right here. The three vowels are all together. Right? Okay, let's look into the last one. We have O here, we have E here, we have U here. Well, once again, the three vowels are not together next to each other. The three vowels not together. So anyways, if we look into the three vowels in each arrangement, would you say there are actually only two possibilities? The three vowels are either together, like this case, or the three vowels are not together. You know, these three other cases, right? Yeah. So those three vowels either together or they are not together. Right? Simple as that. right? For example, guys, I can even give you, how about this one? Say COMPUTER. How about this case? Now let's look into the three vowels. For this case, guys, O here, vowel, U here, E here. Are the three vowels right next to each other? No. Still no, right? Because here we only have two vowels together. But this question, we are talking about all three vowels, either together or the other case. All three vowels are not next to each other, not together, right? So in this case, although we have two together, that still doesn't satisfy the second question here, correct? Because for the second question here, we want all the vowels to be next to each other. That would be this case, right? So even this, three vowels are not all together, right? Yeah. So even for this example right here, that's still what? That still goes into this category, right? Right. Vowels, three vowels are not all together. So anyways, so guys, think about it. We have two possibilities, right? The three vowels are either all together or they are not all together, right? That's it. Can you see? Good. So now, here it is. So we only have two possibilities. One is what? The three vowels are all together. Are together next to each other. Next to each other. What's the other possibilities? They are not next to each other, right? So the other possibility is they are not next to each other. Three vowels are not next to each other. Next to each other. Are not next to each other. Right? So either together or not together. Right? Here it is, guys. Guys, if we add up these two cases, that represents what? All the possibilities. Which is how many possible arrangements? A factorial arrangements. Here it is. For three vowels to be all together next to each other. Didn't we already find out the number of arrangements for this guy right here? For the first case? Yeah. That's the second question. Three vowels all together. Okay, so guys, for three vowels to be all together, for three vowels to be all together, how many ways are there? We already found it, guys. 4, 3, 2, 0. Okay. 4, 3, 2, 0, right? So they are 4, 3, 2, 0 arrangements. Okay, guys? So now the question asks you this. Now, for three vowels, not together, not next to each other, how many are there then? Guys, oops. That's an ugly question mark. Let me do it again. So guys, for three vowels, not next to each other, how many are there? So it's almost like this. In total, I have $10. Okay? If somebody steal $2 away from me, $10 minus $2, guess what? I still have $8 left, right? Same idea here, guys. If you add up all the possible arrangements, right? Because if we add up the two cases, that represents all the possible arrangements. And how many are there? A factorial. And we already found out for the first case. For the first case, How many arrangements are there? 4320. 4,320 arrangements. Then would you say this number, subtract this number, whatever left is here. It's for case number 2, right? That's it, guys. So, for question number 3, how many different arrangements are there when the 3 vowels are not all together, are not next to each other? Easy. We just go all the possible cases. That would be a factorial, right? A factorial minus, actually I don't need the bracket here. Yeah, a factorial minus what? All the possible cases, all the possible arrangements minus this number, and whatever left is this, right? Yeah. Okay, so a factorial minus this guy right here, 4320, minus 4320. Okay? Because whatever you have left is the number of arrangements for case number 2, right? Cool. Yeah. So let's go. And by the way, what's the answer then? So the answer will be a factorial minus 4320. It's a pretty big number. 36,000. Okay? Yeah. So guess what? How many arrangements are there for case 2? 36,000 ways. Okay? Yeah. Okay, let's make some note. So the a factorial here represents all possible arrangements with no restrictions, right? This guy right here, with no restrictions. Subtract by what? This 4320 represents the cases with all the vowels. All the vowels together next to each other. Right? So all possible minus the cases that you don't want equals to the cases that you want. Right? Yeah. So this represents all vowels not. So the opposite of this, right? All vowels not next to each other. Okay. 2. Okay, guys, that's it. Pretty cool, right? Yeah. So, guys, we're gonna use this idea, very often for the rest of the chapter. Okay. So, whenever you wanna find something you are looking for, guess what? One way to do it is you find all the possible cases minus the cases that you are not looking for. Whatever left are the number of cases that you are looking for, right? That's it, okay? Good.